All right, so yeah, this is one that I even have whole slides about. So, I mean, well, I mean, can you see it from here? Can you read that? Right. It's so. This question was on some test last term. So you have to kind of figure out what it's saying, right? And we can roll backwards, right? Get rid of all of this stuff and say, what is this saying? Right? So the line there, y plus a equals 0, tells me that x times. Oh, this is a different question than I wanted. Right? So now let's so if this is true, right? We then how is this going to be true? Well, we either make this guy 0, right? Or we make this 0. And how do you make this 0? Right? This is going to be 0 there. Right? They're negative.
Here's the thing, is it like for all just be arbitrary? So like why do it and 0?
Well, I'm just right now, I'm just studying this inner thing here. Right? I'm ignoring all that outside right now. Let's just look at this inner sentence. Right? And I need sums in order to play the game. Whenever that comes up with an exist, I have to come up with an exist, right? The for all is easy because you say arbitrary, right? So before I play the game, I can study this and say, when is this sentence true, right? And soon as you got a times equals 0, then you should know, well, either this is 0 or this is 0, right? So maybe I can set y(x) to be 0. Or maybe I can somehow set this to be 0. How do I set this to be 0? Well, I get them to be negatives, negating to each other. Right? So that gave you some understanding. So now, let's just hack the game. Right? I mean, we could roll it out. Right? If we roll it out and get some meaning, then we do kind of one layer at a time. And we say, this is better be true for all x, right? So no, x is 0. So we better have this, right? So this is our guide. Then we can roll it out further and say there exists a y. Well, I'm going to have to come up with a value of y, right? What's my y going to be? My y is going to be this, right? And then I roll it out forward further, and I say for all a. All right, well, that's okay. I can handle any a, right? So I got some intuition by rolling it backwards, right? Everybody kind of follow that? And then I throw away everything I did, and I start playing the game. Well, let's play the game now, right? For playing the game, it says, what do I write down? I just read it from left to right. All right. I mean, let's do it again. Let's say we don't even have that intuition. Let's just hack in here and say, all right, I got no brain whatsoever, and I'm not going to panic, right? So I read it from left to right. It says for all A, what do I write down? Let A be arbitrary, right? And then it says there exists a Y. So I write down let Y be, I don't know quite yet what to make it, right? But Y is some function of A, right? And then it says for all X. So I say let X be arbitrary. All right. So this is really my only flexibility. And then I come up with this statement, right? I look at this statement and I kind of plug in my values, right? Here, this here is arbitrary. And this here is arbitrary. And then I think, what is my power? My power is to set Y, a value of Y to make this true, right? And so in some ways, what I need to do is I have to solve for Y, right? Which Y's make this true? And it's a little hard solving for Y because I have this bit over here, right? But so now we can kind of think a little bit by cases, right? If our adversary, right, we don't know what our adversary gave us. If our adversary gave us 0, we would be laughing, right? So there's a case in which X is 0 and we know what to do. All right, he probably didn't give us 0, right? So now we kind of know that X is not 0, right? And if X is not 0, we can divide through by X. You can't divide through by 0, but you can divide through by X if it's non-zero, right? So now we get Y plus A is 0. And now I need to solve for Y. I get Y equals negative A, right? That was pretty good. I got a value of Y. So again, I erase all of that stuff because that was just me thinking. And I come back to the game again. And the game says, let A be arbitrary, let Y be what? Oh, I know A. I can set Y to be negative A, right? And then I let X be arbitrary. And then I come back up here. I say, can I make this true? Well, I do left-hand side, right-hand side. Left-hand side is this. And this equals, well, I don't know X. I know Y. I don't know A, right? So I plug it in. And then I go, well, that's X times 0. Oh, that's 0. And I'm done my proof. Right? Does that make sense? That was a really good one to ask.
There exists a Y for all A for all X. That would be false, right?
Okay, let me hear it again. What are you doing?
Exists a Y for all A, all X.
Yeah, is that true? All right, well, let's do the opposite, right? If you don't think it's true, then negate it. For all Y, there exists an A and exists an X. All right, so that in which they're not equal. All right, so somebody gave me, oh, no, this is very much true. Oh, yeah, oh no, yeah, this one's true, exactly. Right? You give me an A, you give me a Y. So what do I set? We go let Y be arbitrary. And now, I mean, the thing is, when you're doing not equals is almost easier. You can basically throw in a random value and it won't be equal, right? So the only danger here is A is equal to minus y, right? So here, let A be minus y, that's the one that's dangerous. And to make it sure that it's not that, we have what? Right? And then, now I kind of come up with an x. What's going to make x? No, it's an exists.
Or create zero. Anything but zero.
Anything but zero. Anything but zero. That's what we want. Right? And then we get 1 here and 1 here, which equals 1, which is not 0. Yeah.
Negating like there exists a y for all x. Is that like contradiction then? Like
Yeah, that was what you just asked. I'm going to say no. Proof by contradiction is I want to prove something is true by assuming it's false, getting a contradiction, and then knowing your assumption that it's false was false, and so it must be true. To me, that's roundabout, right? I call this a direct proof. I want to prove it's false. And how do I prove it's false? I prove that its negation is true, right? I mean, you might even notice in proofs, right? If you go through a proof in the purple table and you have a line that says not alpha, what does this even mean? It means that not alpha is true, which means that alpha is false, right? So really the way you prove that alpha is false is you prove that this negation is true, right? So that's what we're doing here, right? Yeah.
All x and then exists y and then y.
For all
X equals y. And it's y.
oh, buddy, we slap you around.
We're supposed to know, that's why I'm just doing.
Yes. So to me, remember Clockwork Orange and the guy holding up his eye. This is exactly what motivated me to teach this course. That students wouldn't understand the difference from this. And how do you expect me to prove anything in future courses when we don't know this? All right. So we do it. Look at the brackets. Right? We do brackets like this. Right? This is saying every x has some property. Right? What's the property? Right? Well, this one's saying there exists one y that has some property. Right? So they're right now they're already very different. Right? Because this one is talking about the existence of one y. Right? There's one y that works for every x. Right? This is manually known. That's by Einstein. Right? This is 0 that you can multiply by anything. Well, this says for any x, there's a y. Right? So each y could be different. This y can be some function of x. Right? If we're playing the game, x is arbitrary. Then I get to come up with y. So y is a function of x. Y can depend on x. Every x has some y, but it could be a different y for each x. Why? Because I got to come up with the y in the game, but I come up with the y after I know the x. Right? Well, there has to be one y. I had to come up with a y now that works for every x. Right? I mean, let's again play the game. Right? In this one, you're my adversary. You go first. You come up with an integer x. Give me an integer. 2. I come up with 3. It's bigger, right? I'm going to win. You come up with 1 billion. I come up with 1,000,000,001. But now I got to come up with my number first. I'm going to lose, right? Because if I come up with I need a big number. I come up with 1,000,000,000,000,000,000,000,000,000,000,000. You're going to come up with a bigger number, and I'm going to lose, right?
First one, you make y based off of x, but the second one you don't know what x is.
Yeah, right. Here's the big difference. If we were going to simplify them, sometimes I also use this simpler notation, right? I can write this one in saying free variable x, and this is some y that's a function of the x, right? This is saying for any x, you plug it into this function, you'll get a y, right? But this one's saying there's one constant y, right? That works for every x. Right? Does that make sense? Yeah.
One like there exists a girl that every boy loves, and then the top one would be like every boy has a girl he loves.
Yes. Right? This one is Marilyn Monroe. This one is everybody can love different people, right? This one says every voter has a politician he loves, right? It could be Biden, it could be Trump. Or for some of us, yeah, it could be find somebody, let's move over to Bernie Sanders, Down here, is there one politician that makes all of them happy in your dreams, right? This is also the one example. There exists an algorithm that works for every input, right? As opposed to every input has an algorithm.